Let's look at 2.4 part 2. Okay, we're going to look at Chebyshev's theorem. Now, I'm sure there are other ways to pronounce that, so we're just going to call it C's theorem. What happens is this is a way to estimate. So this was before we had all these fancy software packages like StatCrunch and other packages that help us find this without having to estimate. But we still learn this. So K is going to be the standard deviation. And the way that we can estimate this area under the curve is we can take 1 minus 1 over k squared. Now, this isn't a great estimate, but it's an estimate. So let's say that I tell you that k is equal to 2. Then we're going to take 1 minus 1 over 2 squared. So that's going to be 1 minus 1/4, which would give me 3/4, or that would also be 75%. All right, I wanted to add one thing here, that k is going to be the number of standard deviations we are away from the mean, which will make sense in the next problem. Okay, so we're going to do this problem twice. First, we're going to do it all laid out here, and then we're going to go to the next page and we're going to start over. We're going to do it again. Okay, so we have a sample size of 12. So n is equal to 12. The mean number of televisions per household is 2. So that means x bar, the sample mean, is 2, with a standard deviation of 1 television. So S is equal to 1. All right, we're going to use C's theorem to determine at least how many of the households have between 0 and 4 televisions. Well, the problem is right now we don't know how far away we are from the mean. So what we're going to do is we're going to go ahead and put the mean in the middle. So 2 goes in the middle. We're going to add the standard deviation on the right-hand side. So the standard deviation is 1. So we're going to add 1. We're going to start with the mean of 2. We add 1, we get to 3. We add 1 more, we get to 4. If we kept going, we go to 5. On the other side, we're going to subtract. So we have the mean of 2 in the middle. We're going to subtract 1 to get down to 1. We're going to subtract 1 to get down to 0. Doesn't make sense to go any further because we can't have negative televisions. Okay, so they want to know how many households have between 0 and 4 televisions. So that means, I put my number line on here again, that means we want to know the area between 0 and 4 here. Well, what happens is we are 2 standard deviations away on this side. We're also 2 standard deviations away on this side. So that's telling me that k is equal to 2. So let's come over here to our formula, our C's theorem. We're going to put 2 in for k. That gives us 1 minus 1/4, which gives me 3/4, or 75%. So this area under the curve, all of this area, makes up 75% of the data. But that's not what they asked me. And notice when they have an answer block, there's no percent there. They want to know, based on that percent, that 75%, or the 3/4, how many households out of the sample of 12. Now, I know that's not what the wording says, but that's what they want. So I'm going to take the 75% times 12, or here I took 3/4 times 12. That gives me 9 households. So what we know, based on this area under the curve being 75%, and our sample size being 12, we know that at least 9 households will have between 0 and 4 TVs. Okay, let's go to the next page and do this again. Okay, so we know that the sample size is 12. We know that the sample mean x bar is 2, and the sample standard deviation is 1. So let's put our mean in the middle. Remember, the mean always goes in the middle. So 2 is going to go in the middle. We are going to add the standard deviation on the right-hand side. Well, the standard deviation is 1. So 2 plus 1 would give me 3. 3 plus 1 would give me 4. 4 plus 1 would give me 5, and so on. On the other side, I'm going to subtract the standard deviation. So I'm going to subtract 1. So if I subtract 1, I get 1, and then I get 0. Negative doesn't make sense for this problem. Okay, so that's how my number line is set up. But now we want to know the area. Remember, my mean is in the middle. We want to know the area between 0 and 4. So what that tells me is I'm 2 standard deviations away on this side, 2 standard deviations less than the mean. I'm 2 standard deviations on this side, above the mean. And so that tells me that k is equal to 2, not 4. We're looking at how far away we are on either side. And so it's, we're 2 standard deviations away on each side. So now we're going to take that k of 2 and put it in the formula. So my formula is 1 minus 1 over k squared. So that gives me 1 minus 1 over 2 squared, which is going to give me 3/4. Now, if they had just asked for the percent of households that have between 0 and 4, then I could change that 3/4 into 75%, and I would be done. But that's not what they asked. They asked at least how many households. So I know I have the 75%, but now I'm going to have to take that 75% times the 12. That's the sample size, and that gives me 9. So that's what this C theorem is telling me, that at least 9 households, because that's 75% of my sample, have between 0 and 4 TVs. All right, last concept for 2.4. This is the coefficient of variation. Again, StatCrunch is going to take care of this for us, but what happens is this just shows us the standard deviation as a percent of the mean. So it's just another way that we can look at variation when we have a couple different types of data and we want to compare them. And so what's going to happen is if it's the population, we're going to take the sigma, the population standard deviation, divided by the mean. So you're looking at the percent, basically, of the standard deviation to the mean. And then here, for sample, same idea, it just would be S and X bar. All right, so for this problem, it says the ages in years and the heights in inches of all pitchers for a baseball team are listed. Find the coefficient of variation for each of the 2 data sets and then compare the results. So we first have to click on this box right here. That gives us the data box. And that also gives us the box where we can hit StatCrunch and have all the data come in. So we're going to hit this box. That takes us into StatCrunch, and it also brings all the data with it, so we don't have to retype. We're going to go to Stat, Summary Stat, Column, and then let's look at the next screen. Now we want to look at both of these. We want to look at the height and the age. So when you go up here to select the column, you're going to click height first, and then you have to hold the control key down in order to get the age also. Otherwise, it's going to flip-flop to age. So if you want both, you click height, hold the control key down, hit age, and then we'll get the data for both of them. Now, when you come down to the statistics, the coefficient of variation is almost all the way to the end. So you have to scroll down, and you'll see coefficient of variation. So hit compute, and we get our 2 coefficients of variation. So remember, this is the standard deviation as a percent of the mean. So for the height, we get 3.5. That's a percent. For age, it's 15.7. So if we have a larger number, that means that the data is way more variable. Okay, so the larger the percent, the more variable we have. And so in this case, the ages, the standard deviation is larger compared to the mean. And so we have more variability. And that's why I clicked down here. Ages are more variable than the heights of all pitchers on this team.